So, in keeping with me reviewing small things like the Nano VNA and the Tiny SA, I wanted to review one of these new pocket oscilloscopes. So, pocket oscilloscopes have been out quite a while, but I've never been interested in them because they usually top out around, you know, the old ones like a megahertz, and then they kind of went up to maybe, 20 megahertz at maximum, something like that. And Banggood reached out to me. So in full disclosure, Banggood set this in. I'm not being sponsored by them, but they did send this in to the channel. And I told them I was interested in something with a good bandwidth. And so we talked about several options, and this is the one that seems pretty good. So it claims to be a 120 megahertz oscilloscope, and it's in the right price range. So it's a $70. I'll put a link down below. But I think it's $70. And single channel scope, $70, digital, of course. So what do you get in the box? Let's take a look at that. Let me zoom out a bit here. So comes in a little tote bag and official Naga hide. And there we go. That's the unit. So it's pretty tiny. Let's compare it with a Nano VNA, the 4-inch version, because I think that's pretty comparable. So this is a 4-inch Nano, and you can kind of see that it's actually a little small. Well, it's about the same width, and maybe a little smaller vertically, but it's fat. It's about twice as thick as the Nano, but definitely in the pocket range. So we'll do a bunch of tests on it, but let's just see what's in the box. Comes with a charger cord, just a USB micro. Comes with an oscilloscope probe. So let's pull that out and take a look at that. Looks very generic. These are usually pretty decent. It does come with the clip. These are usually okay. I've used these types of probes before, and they're fine. And it comes with all the little accessories and the compensation adjust here on the unit. So it comes with that. So that's nice. And it comes with an instruction manual. So let's take a quick gander at that. I want to read the specs on it. Tells you how to use the menu system stuff. Like I said, I'll learn how to use this thing, and then we'll go through and run it through its paces. Here we go. Here's the specifications. 2.4-inch color screen, 320 by 240, so that's a lot like a Tiny SA. Display technology TFT waveform, so it says 120 megahertz of bandwidth. It has a 500 mega samples per second sample rate. Storage depth, 2.8 divisions. I'm not quite sure what that means. Input impedance 1 megohm. Vertical sensitivity 550 millivolts to 100 volts. 6 nanoseconds to 50 seconds. Wow, 50 second sweep time. That may be handy. Trigger mode auto, normal, single. Rising, falling edges. It has a one-click auto button, so we'll see how that works. It can store up to 2,500 waveforms. Wow. Waveform manager, voltage accuracy says 10%, frequency 1%, measurement parameter 12. I think on the screen you can measure like peak to peak or RMS and things like that. I think there's 12 different things you can look at. Lithium battery, 8-hour standby. It has a backlight. It's a color LCD. Charging voltage, blah, 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 blah. AC-DC coupling, yeah. Looks like typical specs, and yeah. So let's take a quick look here. The buttons on the front feel good and good quality. They're like rubber buttons. It's not light, but it's not heavy. It feels, maybe it feels like twice the heaviness of like a Nano or something like that. Has a little flip out stand on the back. That's nice. What kind of buttons? We have menu, F1, F2, save, AC/DC, ×1, ×10 for probes, 50%, I think that's for the trigger level, trigger, edge, positive, negative, you know, arrow keys for everything. These are for the triggers and these are for everything else. Here's the auto button, so it automatically tries to find, goes onto a signal. You know, I rarely use that on oscilloscopes, but every once in a while it's nice to have. Start, stop for the digital. And then on the side it has a charging port here. And on the bottom is the power button. So let's turn it on. And I'll just take a quick look at it. Looks pretty nice. Everything's readable, good font. Yeah, not so bad. So yeah, let's put some signals in it, see what it does. Okay, so I'm going to be using my my function generator. It's an HP 33120, and I'm going to run this direct. We're not going to use a probe. I'm going to run it direct into the oscilloscope with a 50 ohm load, and I am currently outputting 100 kilohertz at 1 volt peak to peak. So I'm going to hit the auto button, and it says adjusting, and there you go, boom. Comes up with a square wave. Let me go over to the function generator and hit sine. That looks like a sine wave to me. Sine wave, square wave, triangle wave, and so it's pretty zippy. If you notice, there's no delay between things, so it's refreshing really quick, which is good to know. And so we can play with some buttons, I guess. So we have the horizontal buttons, very quick, very nice. That buzzer is going to drive me insane, so we'll have to learn how to turn that off. And then ooh, too much. And then you can change the vertical as well. And if you go too far, it just goes wacko. It's wrapping around and gets to be like a negative overflow on the ADD. So they don't clamp it. That just kind of goes crazy. That's okay. And then there's these are the trigger. So if I go off the top, it's no longer triggering. I don't know if you can see that little red arrow over there, but there's a red arrow, and you can bring that back down. And if you hit 50%, it takes it to the 50% on the waveform and locks in. So everything seems to be pretty good. A little bit of jitter in it. It's definitely doesn't have any smoothing algorithm for the trigger. It's like taking the raw data, and so it's wiggling back and forth one of the sample points. Okay, let's see here. Let's see. We have modes. Let's see. I think what we do is trigger. Trigger says single, and we'll hit trigger again. It says normal, and then auto. All right, and so we can put it into single shot, and we can hit the stop button, and it automatically grabs things. So I'm going to change to a sawtooth wave, and then I'm going to hit the stop button, which is going to go, and boom, it captured a new one. So that works. And then single, let's see, we were doing auto, so the other one is normal. And if we go off the top of normal and it doesn't do anything, it just stops refreshing. So yeah, there you go. So I guess that seems to be reasonable. It's giving us some numbers here. It says volts peak to peak, 0.784, should be 0.707. If my math is correct. And it's saying it's 99.2 kilohertz, and it's actually 100 kilohertz, so certainly within 1% there. And volts peak to peak. I guess it's displaying one set of numbers down here, and then on screen you can select a different set of numbers. So I'll have to figure out how to use all the menu systems, but that seems to be going there. I'm really curious if we can how fast this thing will go. So let's go ahead and ramp it up. This frequency generator only goes to 15 megahertz, but we could take it up that far. So Let's go to frequency 1 megahertz, and then we can use the little horizontal things here to zoom back in on it. So it's working with 1 megahertz just fine. And then let's make it go faster. Is it losing? Not really losing much, maybe just a tiny bit. We'll go up to 15 megahertz and zoom back out. So it's starting to get a bit crunchy. You can see the waveform, it doesn't have a good smoothing filter in the algorithm, so you're getting a little bit of crunchiness in the sample periods. So it's kind of like a straight line draw. I don't know if they do like a sine x over x or whatever that function normally is. They might have not had enough bandwidth in the microprocessor to do that, but it's doing a reasonable job up to 15 megahertz. So pretty pleased with that. We can take a look at the voltage here. It says 693 kind of thing, and then we go down to 4 megahertz. It's yeah, it's gone up a little bit. So it's dropped just a tiny bit at 15 megahertz. Just a tiny bit. All right. So it claims to be 120 megahertz. So that's going to be the big one. So let me get set up here to introduce some higher frequencies. This generator tops out at 15 megahertz. All right, I've changed function generator. So I'm now using my RF generator on my HP 8921, and I'm outputting 15 megahertz, and I'm outputting 1 volt peak to peak, and it's measuring 950. So that's fine. So let's go up in frequency. Let's see here. Let's wait a minute. 15. Let me. Okay, so I'm going to go up in frequency. Here is 25 megahertz. How are we doing? Zoom in a little farther. We're down a little bit, 0.77. Let's go up to 35 megahertz. This is 35 megahertz. It's saying 35.7, and we're dropping a little bit. So when this number here reaches 500 millivolts, we're going to be at the 3 dB point of the 6 dB voltage point of the meter, and that's where it should be spec'd. So let's keep going. How are we doing here? That's fine. And oh, we've gone too low, so I've got to back up. Now back up. Right there, go up a little bit. All right, so if I were measuring this unit, I would say that it is a 45 megahertz oscilloscope, okay? 45 megahertz, it's still giving you a nice looking image, but it's true specification. If you're an oscilloscope manufacturer, this would be a 45 megahertz scope. Now, that's a whole lot better than other little handheld oscilloscopes. Certainly isn't the 120, so that's a bit disappointing. Let's take it up farther. Here's 50 megahertz, and we're down here at 440. Let's go up to 60 megahertz. So 60 megahertz is half of its published specification, and it's 0.35. So, you know, I might have let them slide if they spec this thing at 60 megahertz, but there's no way it's 120 megahertz. There's just no way. But it's certainly, you know, I think, you know, theoretically you can call it a 50 megahertz scope. 60 megahertz scope's probably pushing it a bit, but it's certainly usable at 60 megahertz. Let's go up. Here's 70. Can we make it bigger? Yeah, see, it's starting to not digitize quite correctly. It's starting to get some wiggles in it. It's not digitizing correctly. It can't keep up with its algorithms and stuff. So we're here at 70 megahertz, and it's just not operating well. Let's go back to 60 megahertz. And 60 megahertz, it's also kind of wiggly. Definitely kind of wiggly. you can see it there. So yeah, I would say, don't use this thing above 60 megahertz. Let's keep going because I want to see this 120 megahertz to see what it does at all. So here's 80 megahertz. Now we can, oops. We can still, why am I not? There we go. Huh. Okay, so we've topped out. We're at 6 nanoseconds is as fast as this thing will go. And it is popping up and down. It's got that problem with the... Okay, so let's go to 90 megahertz. And let's go to 100 megahertz. And let's go to 120 megahertz. All right, so it's definitely failing at 120 megahertz. It just doesn't know. It doesn't know what to do there. Let's go back to 100 megahertz. So it's reasonable there. So it seems as though it's usable, say up to 100 megahertz. Definitely spec-wise, it's a 60 megahertz scope. Being generous, being ungenerous, it's about a 50 megahertz scope. But $70, not so bad. It is a single channel though, so that is a consideration to take. Okay, well, we got that out of the way. Let's take a look at some of the other menu items here. So waveform, voltage, time, generator out. Oh yeah, it's got a generator. It's got a calibrator, and I think you can do things with that generator. Yeah, 100 kilohertz, 10 kilohertz, 1 kilohertz, and 1 megahertz. So you can set things on the little clip here and calibrate or use it. Auto's 50%. So when you hit the auto button, it does a 50%. Trigger, I think. It has a light. You can change the grid. Let's see if we can get rid of that darn beep. There you go, beep. Off. Ah, that's better. I like that. Okay. Let's see here. Voltage. Peak to peak. Voltage peak. Voltage Vmax, Vmin, Vaverage, and Vrms. Oh, VRMS, that's cool. Oh, you can turn a whole bunch of these on. Oh, look at that. Let's turn them all on. Okay. Oh, there they all show up. So that's really nice. That's kind of like the Rigol measure button. You can get all these cool things. So that's very nice. And you can turn them off. Let's see. I don't want that one. Let's say I just wanted RMS. And... yeah, there you go, a little RMS down at the bottom there. That's nice. And then time, and then you can display, let's display the period too. Yeah, there's time, 10 microseconds. Cool, I like it. Then you can do pulse widths and duty cycles and stuff. Yeah, it's reasonable. Okay. What else haven't we done? There's F1. I don't know what that does, and F2. I don't know what that does. Okay, I need to read the manual, I guess. I'll put a link down below. There's a video on using all the modes on this thing, I think, and I don't want to repeat that, so I'll just put a link down below. There is a save button, save successful. I don't know how you recall them. Maybe they're on the. Maybe when you hook up the USB, you can read them off. Let's see here. Can you recall? How do you recall? What if I hold down the save button? No? I don't know. Like I said, I need to read the manual. But I just wanted to see kind of the normal things here. Let's see, it's yeah, AC/DC changes there, and then the ×1 and the ×10. So that works for the voltage mode. Yeah, so I think that's a pretty good introduction to this thing. So if you're looking for a portable scope, I would definitely consider it. If you're looking for a first-time scope and you don't have a lot of money, it's maybe or maybe not. You could get a used oscilloscope that's maybe a 20 megahertz oscilloscope that would have a whole bunch of dials, and it would act more like a big oscilloscope, and that might be better for you if it's your first time for learning and stuff. Otherwise, again, if it's your first time, though, this would definitely be a recommendation as well, because it is affordable. It is something you can, keep in your bag. If you're going to school or whatever, you could pop it in your bag. It's certainly a whole lot better than other pocket oscilloscopes I've seen. So the technology is definitely keeping up. I believe I did see a teardown on this unit, and it basically is one chip, right? There's nothing to see inside. It's basically just one chip, and everything is sort of integrated these days. But yeah, let's try a couple things out. Let's see if it can look at strange waveforms. We were kind of looking at periodic waveforms. Let's look at something a little odder. Let's take a look at a sync. That's a sync function. So it's not triggering well, and that's because we're triggering here at 0. So if we move the trigger point up, then it's grabbing these peaks, and now it's triggering. Now it's triggering fine. So there's a sync pulse. That looks quite reasonable. I like that. All right, and we can watch. We could do a. Oops. Let's see here. ARB. We could do a. Oh man. I am screwing things up here. ARB. ARB list. There we go. Let's do my favorite. This one. So cardiac pulses. So that's fun. So it's able to look at that and it's able to trigger on those. Oh, I pushed some weird button. Let's see if it does auto in this mode. We'll do auto. Nah, it doesn't like to do auto in this. Let me go to sine wave and then hit auto. Yeah, it does auto really well for easy things. I knew we would get in trouble with that other one, but it was displaying things correctly, and yeah, I could definitely give this give it a thumbs up.